Good afternoon, and thank you for joining me on what is our final Warren and Brown 2020 webinar. I'd like to thank you for taking the time, and also thank Warren and Brown Technology for their support in enabling these webinars throughout what has been a very challenging year for all of us. In today's session, we're going to take a look at the changes to cabling standards, and there's been some significant changes over the last 12 months, particularly in Australia. And we'll look at the way these changes are going to affect the design of our digital infrastructures. Some very important structural changes to the mandatory standards. When I say mandatory, I'm talking about those that fall under the regulatory banner. So in Australia, they would be managed by the Australian Communications and Media Authority. And when we say mandatory, we refer to the fact that they're backed by legislation, which means that they're backed from a legal standpoint. So if you're in breach of these mandatory standards, then you can find yourself being issued with fines, and in a serious case, you could end up in jail. So worthy of note if you're in the cabling arena, either as a manufacturer or an installer or a consultant or an end user. All of these changes are very, very relevant and important. We know that for certain, one of the big impacts of this global pandemic has been to bring about an awareness of our dependency on reliable technology and the part it's playing in keeping our society and our economies moving, when everything else we consider normal is in lockdown. Whether you're working from home office or, as we discussed in earlier webinars, or industrial premise, a data center or commercial building, technology has undergone a huge shift in functionality. And it's really at the center of much of the remaining economic momentum that will be necessary for our economies to properly recover from this pandemic. We're also going to take a look at some of the risks right at the end associated with digital infrastructures as they relate to business continuity. Business continuity is a field that every organisation really should have a business continuity plan and a business continuity management strategy in place. So a digital infrastructure certainly falls within the realm of something to consider when you're looking at across your organisation at business continuity planning. We'll respond to any questions at the end, just in order to keep us on time. I expect we'll probably be wrapping up in about 40 minutes. Depending on how we're tracking, we'll see if we can get back to you today, but we'll be happy to respond to you via email after the webinar. Okay. Firstly, just a little bit about Warren and Brown. Coming up on 100 years of manufacturing excellence within Australia and globally. When we say manufacturing, they're manufacturers of copper and fibre solutions. They're experts in convergence, provide a lot of tailored solutions. I think in the last probably 5 years, you've seen a doubling of the R&D capacity within the headquarters in Melbourne. And certainly a lot of bespoke capability in terms of manufacturing and prototyping that's available in the Melbourne facility there. So, if you're ever looking at a situation where you need a specific product or an augmentation of a specific product, then certainly Warren Brown has the capability and capacity to help with that. There are systems that offer a 25-year installation warranty, and along with a certified integrator program that Warren and Brown operates as well. So let's look at what's changed. Sometimes I feel in this industry like things are happening very slowly. A great example is to ask your cabling provider if they have an ACMA registration. I was in one of these conversations just last week, and the guy hesitated, gave me a bit of a vacant look, And so I said to him, an Austel license, which he immediately gave me a positive response and said, "Oh yeah, Austel." Well, you know, Austel as a brand was a huge success. It's probably right up there with, I'm old enough to remember a thing called a Valiant Charger, and there was a fantastically popular and successful advertising campaign that went along the lines of "Hey Charger" with a V for Valiant instead of Victory. The fact is that Austel licenses were replaced over 20 years ago by the then ACA, which is now the ACMA, and it's a cabler registration program. So yeah, Austel was, you'd have to say, a marketing success, because not many people seem to know what a registration is, but they know what an Austel license is. One thing that certainly changes the way that we are using communications cabling as time is moving forward. Historically, we obviously used it for support of voice telephony, and it grew out of that into structured cabling. And these days, it's moved into support everything from power delivery to high-speed data communications, security, CCTV, building automation. That's just to name a few. So what it's going to mean, and what I'm seeing certainly on premises and in operational situations, is that there's a growing need now for us to understand that we can reliably use this cabling to transmit all of those things that I mentioned and many others. But what we do need to be mindful of is, if we're going to do that, there's a call for better integration of technology. So you need to be thinking strategically across your organization about how you're going to get all these various things to actually operate together. Because a lot of what we can do now is achieved obviously through advanced software programs that are out there. There's going to be an increase in autonomous machine capability, you know, deterministic systems that can deal with dynamic inputs and vary outcomes according to required thresholds, time-sensitive things like autonomous vehicles. All of these sensors and systems require better data analytics to enable them to actually do the job that you're hoping they'll achieve. So there's going to be an ever-increasing reliance on reliable data, infrastructures and systems to carry all of that as it needs to be supported. So quite a bit has changed in the Australian standards, and it's been a wholesale change, not just mandatory, but also advisory standards. A couple of the drivers behind a lot of this change, PoE would be a big one. It's been with us now for a couple of decades, and so many of our devices these days are PoE devices. And what it simply means is they derive their power for operation from the same network cable that is responsible for sending and receiving data. So that same bit of category cable that you plug in is powering the device. We're in a situation these days where we have 4 types that are defined in standards. The most advanced or most recent one there is type 4, and a couple of details on that slide there. It's known as IEEE 802.3BT. It can deliver up to 100 watts, and it can deliver that 100 watts over 100 meters. So that really means literally that you can power just about any tech that requires anything less than 100 watts, which if I look at the laptop I'm using here today, you know, it would fall within that category. So, you know, when you start to open up PoE and look at just how much it can support, it's a really wide range of products that can be delivered. You know, you could light an entire commercial building these days using LED lighting systems. LED lighting systems can be PoE delivered, so they don't have to be mains power supplied. So we're now at a point in history where there's a real crossover between what a communications cabler could legally do with the right ACMA coverage in terms of their skills and knowledge and registrations, and what an electrician does. So there's an inherent duty of care then in both directions for electrical to be informing the rest of us through standards what's safe, and equally now, because of these high levels of wattage that we're supplying on comms cable, we need to be letting everybody else know that, hey, some of these voltages and currents and power levels can be dangerous. So we're going to have a little bit of a chat about that. You know, the 23, 24 AWG, American wide gauge cables can support this Type 4. There's also now versions of power delivery, which I'll talk about in a moment, that can use the same size cable and deliver 2,000 watts on a single pair up to 2,000 meters. So some very interesting applications now that are utilizing what we would have considered a normal old data cable. You also have remote powering equipment based on, you know, supplying up to, you've got RP1, RP2 and RP3 are the three categories that are defined in standards. RP3 takes it all the way up to 500 milliamps on a single pair for remote powering of equipment. So, you know, 500 milliamps is certainly could be, in the right conditions, a lethal amount of power. Another big driver, of course, is the Internet of Things. You need power and communications. A lot of devices require low latency. I mentioned autonomous vehicles, for example, industrial process control systems, robotics, automated warehousing. Even in hospitals now, you can do food and pharmaceutical dosage delivery through automated means. So when we have all of that capability and we're wanting to exploit it to the full extent, we need to make sure that we have low latency, that is low delays in terms of the delivery of that data. And, you know, the growth of IoT devices now, we're seeing, this one here makes me laugh a little bit because it's probably 10 years old or so, this particular graph, and I just happened to find it again. And I thought I'd put it up there and just add a correction to it, that it's actually about 20 billion devices by the time we got to the beginning of 2020. But it's certainly not 50 billion devices that are connected. But that's still a huge number of devices that are connected, and it's growing by the day. So, you know, it's certainly something to be aware of. This is the one that I alluded to a moment ago, 2,000 watts to 2,000 meters. It's a trademark, it's digital electricity, and it uses a thing called Volt Server is the product. And Volt Server, what it does, as you can see from the little diagram there, it sends an energy packet of 1.1 milliseconds in length, so a spike of energy, if you want to think of it that way, with a little bit of data attached to it. And what it'll do is it sends that energy packet, around 600 of these packets per second. And if there's a measurable decay in that energy, in other words, if you touched it with your finger or something untoward happened and it caused that energy to roll off at a predetermined threshold that indicated there was an issue, it would immediately stop sending that energy. So what it really does is it makes a hazardous service a safe service. So you know, we're not really seeing broad uptake of this yet, but it's only a matter of time. And it's, you know, it's covered by a couple of the IEC standards. 62.3, 68-1 gives, you know, it meets that, which is approved limited power source. And also IEC 60950-1 and -21, which are approved limited power source receivers. So it uses basically a switch, and it can supply, you know, you look at that slide, you can see there IoT devices, cameras, wireless access points, broadband services, data center servers, GPON devices. So it's going to be certainly one to watch. But once again, we're talking about delivering significant amounts of power over what was traditionally comms cable. Excuse me. Thought it'd be worth just doing a quick recap on the standards and where they come from. We're based here in Australia on the ISO set of standards, and that's been one of the big changes in the last 12 months, has been the full adoption of the 11801 series of standards in Australia, from 11801.1 through to 11801.6, and I'll briefly talk about each of those in a coming slide. The American standards there, TIA, and the CENELEC, which is the European standards, covered as well. This little table here gives you a bit of a bird's eye view of what those standards are. So you can see now that, just to define, where you see SCS, I've taken a bit of poetic license here, and that means structured cabling systems. And I've put standards topic. That's not the full name of the standard. If I did that, I'd need a slide for every single one of them because they're quite big titles. So it's commercial structured cabling systems, industrial, residential data center, and intelligent building service. Then we have our pathways and spaces standard, our administration, which is labeling and the like, planning and installation, testing, both copper and fibre, earthing, and the ACMA regulatory standards down the bottom there. You can see the corresponding ISO IEC, and they track pretty evenly now, except when you get to 3084, it's still 18010 in the rest of the world. That may change eventually, and 3085 is 14763-1 is its correlated equivalent. So the mandatory standards mentioned at the bottom of that previous slide, S008, are the requirements for customer premises cabling products. So any cable, any connector, any thing that sits within the telecommunications customer environment needs to have products that are covered by this mandatory standard. So the latest version, S008 2020, is now out. The industry standard, this version of it, I should say, has a crossover period with its predecessor for about 18 months. And the transition period commenced on the 20th of August 2020, so it's only quite recent. It's the standard documents, also known as the TLN, which is Telecommunications Labelling Notice, is included in here. So this covers all the details as well around labelling requirements for manufactured products. So obviously, why this is important is if we're moving to a world where we're going to be using lots more telecommunications cabling systems for delivering power and higher levels of power, we want to make sure that our devices are fit for purpose and meet these mandatory standards, because, heaven forbid you've got a piece of cable or a connector that doesn't meet the requirements and somebody is injured or equipment is damaged, there's other legal ramifications to that. So very important that manufacturers heed and follow that particular mandatory standard. The other one is S009. Also came out in August this year and has a crossover with its 2013 predecessor. It covers the installation maintenance practices that you must follow. It covers the requirements for fixed or concealed cabling or equipment that is connected or is intended to be connected to a telecommunications network. There's a requirement, if the cabling work is completed by a registered cabler, that you need to fill out a form called which is the telecommunications declaration form. And that needs to be part of the documentation. So I would suggest, particularly with PoE, that particularly the higher levels, that you're getting those forms TCA1 forms signed off appropriately. So what are the updates? Well, I just thought just due to the fact that we don't have a lot of time today, that I'd put up some of the main topic areas there. It is a free download, this standard, so you can actually download it free, and I would advise you to do so. The references to other standards have been updated to reflect international and related national standards. It's much better correlated than the previous versions of S009. There's also clarification on different types and locations of cable. So they fall into categories now like generic, structured, and application-specific cabling. There are plug terminated equipment definitions in there. So we have for things like CCTV, excuse me, cameras, wireless access points, you can now directly terminate a plug on the end of the cable. You don't need to go through an outlet anymore or a TO. We have definitions of types of people included in this version of the standard, and they include everything from ordinary people to instructed people to skilled people. And that's reflected in discussion around, for example, remote powering and who should and shouldn't be in contact with those levels of remote powering. There are new types of outlets now in the standards. There are TOs, there are SOs, there are EOs, there are BOs, and the list goes on. There's revised information and recommendations around flammability and fire stopping. Clearly, that's a very important one to get your head around, given the potential legal ramifications of a fire event taking place. There's updates to fibre optic requirements for inspection and warning labels. Laser safety warnings now are required on any rack panel or anything containing fibre terminations. And that is the responsibility of the registered cabler to make sure that that is all appropriately done. Manufacturers definitely have to play their part, but ultimately the person installing has a duty of care there. There's updated information for inter-building cabling and surge suppression as well. PID access updates for trafficable locations. Updates to earthing requirements for distributors. So the requirement now is that a 6mm earth is required for any distributor that terminates external customer cabling. And there's updated information around network boundary criteria as well. That's to name a few. There is more than that. Digging in to some of the more important ones to take away from this presentation. There's a new naming convention now for remote powering and electrical source equipment, energy source equipment definitions. They come from a standard called AS/NZS 62368.1, and they have been applied. So we now have ES1, ES2, and ES3, and what they're replacing are what we used to call SELV, ELV, TNV, and low voltage telecommunications and hazardous cabling. Those have been appended to the standards, and there is a changeover period for the next 18 months of swinging that terminology across. So, you know, just at that level, if you haven't seen these standards, I can't implore you enough to get hold of them and get your head around how ES1, ES2, and ES3 apply. Just a little bit of definition around them. ES1 is safe to touch for everyone, or ordinary people, as the standard uses as a classification. ES2 is generally considered safe to touch, but there are some extra definitions around some safeguards and who should have access to these, such as instructed and skilled people. And ES3 is hazardous and is only for access by skilled people, really. According to the standard, there's no voltage or current limiting on ES3, so it is truly a hazardous service. You know, we used to define current limited or voltage limited for the, you know, outgoing terminologies. So just be mindful that ES3 is a hazardous service. And this you get an idea then that if you're going to be putting in ES3 services and there's no voltage and current limiting, that you want to make sure your equipment is certainly compliant from a regulatory standpoint. And you're talking about 400 volt DC between conductors and 750 milliamp per conductor restriction on generic cabling. So you can deliver hazardous services down generic cabling, is what it means. Engineered solutions are allowed to address the specific requirements, and that means that you need a licensed engineer, professional engineer in those cases. Different requirements for generic structured and application specific cabling, as I mentioned. We need to think about now separation of cable, power and communications. It's always been a part of these standards, but we want to make sure that all trades are protected. As I said, if we've now got ES3 and we can deliver hazardous services, and we want to make sure that those cables are appropriately dealt with in terms of segregation. If you are delivering ES3, and I, at this point in time, in my own limited experience, have not come across any actual ES3 installations. But what I can tell you is if you did see one, it's required that it uses a specific cable color called Homebush Gold, and that the print on that Homebush Gold jacket is Homebush Red, and they're specified in the standards as well. So really, ES3 is special application cabling, and what that means is that you might have manufacturer equipment that requires ES3 to function, and in that case, there's a clear requirement in the standards where it shall meet the equipment manufacturer's requirements, the intended special application. Anytime, remember, you see the word shall in a standard, that's mandated by law. If you go to an engineered solution, as I mentioned, obviously it carries a greater risk. There is a duty of care, and obviously that's why engineers have, liability insurance, public liability and professional indemnity insurance. But, it's getting into quite a risky area when we're talking about these types of services being delivered. So, not aware of anyone actually doing any at this point in time, but it's possible. So therefore we need to be aware of it. Excuse me. There's strengthening for the terminology fit for purpose. So it needs to provide the required safety and security around delivering whatever service it's delivering. It requires, if we're going to be putting in these ES1 to ES3, then the minimum conductor sizes of 0.5 have been added for backbone and generic cabling. That relates back to 24 AWG. What it doesn't deal with specifically is heat rise, but certainly that is a consideration. So, minimal heat rise is what we're after. If we bundle, if we take, for example, 24 cables in a bundle, which is a fairly typical number that people like to use on catenaries, etc., and we start loading them up with very high power, say type 4 PoE delivery, there's every chance that that bundle is going to overheat to a point where it's going to cause functional anomalies, and you're not going to get the functionality or the service that you're looking for out of that cable. Now, thinking about that, if what those PoE services are delivering, say CCTV coverage of a sensitive area or an area where there's a lot of safety requirements, and indeed that footage could be used if there was a threat to equipment or to life safety, and you now talk about losing functionality due to overheating in the cable bundle, then there's an inherent duty of care then around the way the system is designed, the way it's installed, to avoid that overheating of those cables. So these are the types of things we need to start to, I guess, carry forward in the way we're designing and the way we're applying these new standards. Single pair Ethernet. So the performance standards, another term is advisory standards. So these are not mandated by law, this group of standards. However, if you sign a contract for delivery of this cabling into a premises, and you sign a contract that calls out these standards as compliance documents, then they are legally executable in terms of your need to adhere to them. Some of the things covered, ISO 11801 covers single pair Ethernet solutions. That's been added in now. Class T1A and is specified up to 20 megahertz with multiple channel lengths based on insertion loss specified. So you've got the different levels there. So you've got 1,000, 500, 250 and 100 in there as well. 600 megahertz for T1B and T1C up to 1250 gigahertz to 100 meters. So yeah, sorry, in that first bullet, those numbers relate to megahertz. 11801-1, 3 and 6 cover single pair Ethernet. So where we're mainly going to see single pair Ethernet is being used for building automation systems, replacing serial systems, traditional old Modbus systems or serial control. Industrial automation we'll see replacing traditional field bus using a single pair Ethernet approach. You have a couple of other technical reports, which is what TR stands for there, 11801, 9909 and 9910, covering 9909 covering 25 gigabits and extending that out to 50 meters. And then you've got 9910, which is 14763-4 is the reference document. And it talks about a thing called a modular plug terminated link, or an MPTL. So that's, you know, powered devices once again. One of the big changes or additions, I guess, to the standards is we've come from this background with structured cabling standards of having a CD, a BD, an FD, CP and a TO, as you see in 11801.2, which is office premises. That's still in place, but take a look at some of the other ones. If you look at .3, you'll see that they've added another distributor in there. So now you have CD, BD, FD, ID, which is intermediate, and CPTO, and that can go out to 10,000 meters. So again, this is talking to the industrial control single pair Ethernet type applications where we're using, you know, potentially low data rates, but greater distances to give us an idea of how systems are functioning. Homes, we have PHD, SHD, BOTO, so we have broadcast outlets and telecommunications outlets. Data centers, we have network interface, main distributor, intermediate distributor, zone distributor, local distribution point, and equipment outlet. So it's still a star-based application. If you looked at the topology of all of these, there is still a hierarchical star. It's just that a couple of them utilize extra distributors in them. And then finally, 11801.6 is distributed building services. CD, BD, SD, and SCP and SO. So service outlet, service distributor is what a SD is, and a service consolidation point is what an SCP is. And again, that takes it out to 10,000 meters. Or 10 kilometers. So just looking at it, that's, you know, same but different. So you've now got 4 primary distributors instead of the traditional 3 that we had in the past, which is still appropriate for commercial buildings. So if we looked at the distributed building services, for example, you can see there that you've got your CDBD down at the bottom there. You've got your equipment room, which is housing a service distributor, and we have type A and type B delivery underneath this standard. Type A just goes straight from the distributor to an outlet or through a consolidation point. Type B, on the other hand, goes from the distributor to the consolidation point, and then from the SCP out, that is application-specific cabling. So if you're using a Johnson control system or some form of manufactured command and control system or building automation system, there might be specific cabling that needs to be connected in its own topology going out to the devices, the field deployed devices or sensors or whatever they happen to be from that consolidation point. And in that case, the type B cabling only defines the cabling out to the consolidation point. When I say it defines the cabling, it also defines how that cabling is installed and tested. A modular plug terminated link, as the name suggests, just means that we do what is shown in this slide. You can just put a plug on the end of the cable rather than terminating that cable into an outlet and then using a patch cord or fly lead to plug into the active device. It's specified in 11801-1. Channel testing is not appropriate as it doesn't test the plug on the end of the cable. We had a case of this not so long ago where people were testing one of these types of installations and using the channel test, which is not appropriate. There's a high dependency for links for safety and security systems along with operational service availability. So you want to make sure that those plugs are not just cheap and cheerful plugs that you got at the local wholesaler that doesn't match in with any of the rest of the cabling architecture. You want to make sure that they're rated to the appropriate performance. And indeed, if they're field terminated, you certainly want to make sure that the field termination practices are backed by the manufacturer and that there's plenty of proof that the performance is there, and independent certification of those manufactured products would be a good idea as well. So what I'm saying is really poor connector choice means that you've got a high chance of failure, and poor termination means that you've equally got a high chance that it won't work. So you want to get your ducks in a row there. New copper testing requirements includes testing for category 8, class 1 and 2 systems. There's also a requirement for balance testing of the cables themselves, and what this TCL stands for is transverse conversion loss. Without going into the detail, what we're talking about here is really a measure of how well balanced the wires are in each individual pair. There's another one there, balance testing thing that's not mentioned on this slide, called ELTCTL, which is equal level transversion conversion transfer loss, which is a mouthful. And once again, as an outcome, what it's looking for is how well balanced those individual wires are in each pair. We have DC resistance unbalanced testing. We have single pair Ethernet testing. We have patch cord testing as well, to include category 8, both 1 and 2. If we look at fibre testing, MPO testing is now formally adopted into the standard and defined. It references 61280-4-5 for using test equipment with MPO interfaces, and it defines the testing for all of your components, so your cassettes, your fan-out cables, and your trunk leads. MPL links to support direct connection of field devices, so CCTV, for example, as I mentioned before. There's end-to-end links for direct fibre connection testing are defined, and in the enhanced 3-chord reference method is to be removed. And all of the power meters with testing equipment as well are required to have changeable input connectors. And that's the only reason or only way you can get rid of that type 3 or method 3. 14763-3 single mode testing is to be revised and support cables up to 10 kilometres in length. And IEC standard mentioned there talks about moving to a 3-zone from a 2-zone. What we're talking about there are the end-face classifications of fibre connectors now. So when you use a scope, there is the ability to pass and fail based on a screenshot of that end face. And what it's looking for is the amount of dirt and debris, or indeed scratches, that are present. Formerly, it was using 3 zones. So the core, the inner part of the ferrule and the outer part of the connected ferrule, and it's moving, so it is moving to that 3 zones from 2, sorry. And they're relaxing the scratch detection size requirements. So the size of the scratches that are allowed to classify as a pass have been revised. So all of that in mind, obviously there's quite a bit of change to catch up with if you haven't already, and I'd really strongly recommend that if you're in the industry in any way, shape or form, that you get across those changes at your earliest convenience, particularly the mandatory ones. You know, with more and more cabling supplying power of various levels, ranging all the way through to hazardous levels, as I mentioned before, that could cause damage to equipment and danger to people, you know, there's a risk profile there that we need to be aware of at an organisational level. We're all using this cabling, so none of us are immune from this. Our cablers, our registered cablers, really are considered in standards to be subject matter experts. And so there is a need for the installer, and it is mandated in those standards, that they carry the responsibility if something they install fails or causes death or injury. So you can see, you know, that there's ample opportunity for assessing risk around those things. And not only electrical safety, but cabling is affecting service availability on safety and security systems, as I mentioned before. So if you've just recently done some work in a mining environment, underground mining environment, which wasn't on my bucket list, but anyway, I've ticked the box on that now. You know, and if you've got a mine CCTV system that's monitoring a crusher that's a kilometre below the surface, and something ends up falling into that crusher that could cause it to stop or malfunction, that's going to affect the production of the mining operation in terms of dollars output. So, you know, where's the liability if the cabling is the failure point because of that CCTV footage not being available when something took place that was out of ordinary operation? You know, equally, when you've got 60-ton autonomous loaders moving around underground, and you need to have reliable traffic monitoring and management of those vehicles to avoid collisions with other vehicles. You know, this move towards autonomous does carry with it a certain amount of risk. So our increasing IoT dependency is part of the risk mitigation strategy for many organisations. So we're using IoT as a tool to help us with competitive performance of our organisations as well. So as that dependency increases, then ensuring that it's functional is paramount. So I'm going to leave you with a little bit of homework for the holidays, just like any other teacher would, right? You need to adopt a risk-based approach to assessing your digital infrastructure compliance. And the first point that really suggests that you have an awareness of the compliance that you have in your digital infrastructure that's tied up in the products that are used. So understanding that the products are compliant to S008, which are mandatory at law. So that your contractors or in-house cablers, for that matter, have the requisite mandatory ACMA registrations and the appropriate skills and knowledge on any of the endorsement skills, such as structured, fibre optic, coax, underground pit and pipe, and testing as well. When you're considering your business continuity plans and management, ensure that your technology is part and parcel of these plans. And that extends to the cabling. This would include ensuring you have the right people and processes in place to deal with emergency operations in the case of something like a global pandemic, for example. You need to stitch in the requirements stated in the mandatory and appropriate performance-based standards into the organisation, and that needs to start with procurement through to business operations as usual, maintenance operations, backup, security, emergency operations, and the like. So review that dependency that your organisation has on technology as part of your business continuity. Utilise standards as a minimum set of requirements, or benchmarking, if you like, for determining whether your infrastructure needs are being met or whether there needs to be some revision and review taking place. Obviously, Warren & Brown are suppliers of equipment that meets these standards. Everything is S008 compliant, and the Certified Installer Program or Integrator Program ensures that the installers that have undergone that program are able and willing and able to assist, and making sure that your technology needs are met, and that, most importantly, they meet the mandatory codes and standards. The products are flexible. They support all of those networks that I was talking about: building automation systems, voice and data, security, manufacturing and industrial control systems. There are also fibre optic systems that are available, a full range: patch panels, cassettes, trunk cables, MPO, individual connectors such as LCs. All of that equipment is available from Warren & Brown and meets or exceeds the standards. So there's our contact details, but I'd just like to thank you once again for your attendance today. If you're out there, have a very Merry Christmas and a Happy New Year from Warren & Brown, all of us at Warren & Brown. And from me personally, take care, stay safe, look forward to seeing you in 2021, and let's keep our fingers crossed that it's a bit more of an enjoyable year for all of us. So all the best. If you've got any questions, please drop them into the chat. If you haven't got anything now and you have something that occurs to you later on, just feel free to drop us an email via Warren & Brown's website. We'll get back to you as soon as possible. All right, folks, with that, take care, all the best, and we shall see you in the new year.